Hi everyone, welcome back to my channel Vertex MrRoy. Today we are doing logarithm, change of base law. One of the students just messaged me that, sir, you left 3 questions of exercise 3.6. Thank you so much, first of all, to remind me. And I left this question by purpose. What is my purpose actually? That with these questions, like 3.6, question number 15 to 17, change of base law, we have something to do behind it. Actually, what? That by using these 3 questions, we have to cover up also the past paper questions of November 2001, June 2002, and June 2004. You can see this is change of base law, but second part, this is change of base law, and this second part is also change of base law because the base here is 4, the base here is 2. The base here is 3, the base here is y. The base here is 4 and the base here is 2. This is the change of base law. So we have to do these questions in this video. What we are doing today actually, I just want to show all the questions first before starting my video. So this question, I just want to say something like thank you so much that you remind me for this exercise. But this question with this exercise is very important. Why? This question normally you do not do in the school, but you do with the tuition teacher. Like they know very well this how we have to handle these questions in logarithms. So I am also including these questions, some questions which are very important in your test and also in the past paper question, past paper examinations. And this question is also one of the important part, like 2007 November. This is also one of the very important questions, especially part 3. One more thing I would like to say, this specimen paper of 2020, when you see this question number 10, part B and C, this is also the logarithm question. And in logarithm, this is very simple because there is no change of base law. But when you see the C part in the specimen paper, this is also the change of base law. The base is 3 and the base is 9. So this is the complete topic today, what we are doing today in this video. So if you want to see these questions, please continue watching the video. So let's see and move to the working of these questions. In my previous video, I have already explained this, what is the change of base law. So I discussed 2 rules. The first rule is interchange of base. Interchange of base rule is what? Like just we need to remember 2 rules in the change of base law. The first is when you have log A and B, the base is A. So interchange of base means B will become the base. So what do you have to write? 1 upon log B will become the base and A will come here. This is the interchange of base. Second rule in change of base law is we write the third base. Like third base, this is the rule just I made for my student. The third base means when you have the same condition log AB, but you need not the base B, you need the third base. So third base means you have to write log here, you have to write log here, and the third base is X. What do you need actually? Whatever you want, just write it here, third base. Suppose I need X here, so this B will become here and this A will move here. This is called the third base change of base law. So what we need here, like in if you see 15 part A, the first thing, the base is 3 and the base is X. The X is also here. So what we need here, we need interchange of base. This X should be the base now, so 3 will move. So what I will write, 1 upon log this X will become the base and this is 3. This is the interchange of base. Why we made this? Because X base is also here. Now what we have to do, I just need to copy this log X and 3. You can see log x3 both the same. So what we can do, suppose let log x3 is equals to suppose y, and just when we need put the value 1 upon y is equals to 9 and y. This y and y will become y square and 9 will become, like we can write here, 9 will move down. This is y square. Okay. Y square, when we substitute, like remove the square, we write square root. And remember, when we apply the square root, we write always plus minus. Like we have 2 results. like one time 1 upon 3 and one time minus 1 upon 3. Now this is, we have done it. Now what's the result? Because we suppose we need to find the value of x, not the y, so we have to write here since we write since here, this log x3 was equals to y. So what is y equals to? 1 upon 3. Okay, I'm writing here log x3 is equals to 1 upon 3. Okay, let's see. What we do here, like remember, I also write here somewhere here that when we convert log a b is equals to like c, so what we write, a will become the base will remain the base, and this becomes c equals to b. This rule also remember, this is when we convert the log system to the index form, log form and the index form. So this x will become the x base, 1 upon 3 will come here, and this 3 will move here. So when you remove this 1 upon 3, you have to apply cube both the sides. This 3 cancel out, and x equals to 3 cube is 27. Okay, now we need to put the value here, log x3 equals to minus 1 upon 3. So this x will become minus 1 upon 3, and this is 3. And when we write here, put the value minus 3 and minus 3, this 3 and 3 cancel, minus 3, and this is 27, but 1 upon 27. So what's the result? You can see, I can show you the results here. The result is 27 and 1 upon 27. That's we have done. Okay. So 27 and 1 upon 27 first part we have done. Moving to the second part. Second part is, I have to remove this. This video can be a little bit lengthy, but I will divide this video into two parts. 15 part B. Okay, what we have in 15 part B? The base is 4 and x. The base is x. So it means we need to make the interchange. The first rule. Okay, 4 multiplied by 1 upon, I need the base, this x here. So x and 4 interchange, 1 upon minus 9. This will remain same because we have to make the same basis. So now what you can do, you can suppose let log 4 x4 equals to, you can suppose y. When you suppose y, you can put the value 4 multiplied by 1 is 4 upon y minus 9 times y is equals to 0. When you take the LCM is coming, or you can just shift on right hand side, it's positive, and this 9 y will become y squared. So 4 upon 9 is equals to y squared, and y will become, when we put the square root, is coming plus minus 2 upon 3. Okay, this is y, but we need to find the value of x. So we apply since what we have supposed L log x4 equals to y, and we need to put the value of y is 2 upon 3. So first we put 2 upon 3, and second time we put minus 2 upon 3. Now just we need to simplify. Okay, x is the base, and this will remain the base as we have done here, and 2 upon 3 will become the power, and 4 will move right. And when you remove this power, it's very simple. 2 upon 3, we write 3 upon 2, just reciprocal. 3 upon 2 both the sides. This 3 and 3 cancel, 2 and 2 cancel. Like 2 cancel, 3 cancel, you have only x. And when you simplify, so 2, where you can use the calculator, 2 square, and 2 times this, I think just coming 8. And this x, you can write x power is minus 2 upon 3 is equals to 4. And when you remove this, what do you write? You write minus 3 upon 2, and minus 3 upon 2, x will be coming minus 8, I think so. And you can see the result here. The result is coming here. Sorry, this is massive. This is the result, 8 and 1 upon 8. So we have, sorry. This is 1 upon 8. Okay. So this was the B part. Like when you move, mistakes are possible, please, sometimes in hurry. So moving to the next part is question number C. Okay, C part, we have to use the third base system. Like what we do, this is log 2 x is equals to log 4 x plus 6. This is base 4 and this is base 2. I don't need this x as a base. We don't need interchange of base. We need like 2 and 4, 2 and x. I want 4 as a base, third. So what I have to do, I have to do one thing. What's the method? I will write log 2 times this x upon 2. I write x here and 2 here. Which base we need? What base we need? We need base 4, so I write 4 here and 4 here. This is the easiest method. Like when you want to make third base, this is the base you can write here, and this is very simple. Now this 4 power like x and this 4 with this, what we have to do here, just remember this. I just want to take this part. There are so many other methods to do. I can also make the base of x, but this is, I am just made it 4 2. This one is a little bit difficult. When you have this situation, like 2 and 4 is very simple. What you can do, you can make this as a power of 2, and this 2 will become moved as a coefficient, and this log 2 and 2 is equals to 1, and this is it. But when you have this condition, like this condition, I cannot disturb the base, but I can change this 2. Can you make it 4? Yes, we can make it 4. How can we make it 4? I can make it 4, but I write what? Square root. The square root means the under root 4 is 2. This under root means the power is 1 upon 2, and I have to copy again log 4 and 4. This 4 and 4 is equals to what? 1. So it's coming 1 upon 2. So I can write here 1 upon 2. This is one of the method we can do it. So okay, I am just writing here log 4x. Here I can write 1 upon 2. There is also another method. Maybe I will try to discuss with you. Okay, this 2 1 upon 2, when you move up, is coming 2 only. Now when we have this condition, this 2 will become the power. Okay, this will become the power. So log 4x power is 2 log 4x plus 6. You can see the condition that when we have the same log with the base, we compare. Normally students say we cancel this. Actually we do not cancel this, we compare. So what is left now? X square is equals to, you can see x square is equals to x plus 6, and x square minus x minus is equal to 0. When we simplify this, what are the factors is coming? Minus to get 1, I think so 3 and 2. Yes, 3 and 2 produce a 6. Yeah, and is coming x minus 3 plus 2 x minus 3. So x is equals to 3 and x equals to minus 2. Okay, this x3, when you like x3, here you have log 2, like here log 2x. Remember this situation. This negative is not possible. This x can, like we never have the value here negative like minus 5 or something. It cannot be negative. When this is negative, it means not possible. So this 2 will be rejected. Only 3 will be your result. If you want to see the answers, yes, 3 is your result. Okay, so we have done it. So moving to part D now. So question number 15, part D. Is up to you to make this 5 as an 5 and under root 5. What you want to do, like, is up to you. You can make under root 5 here as a base. You can make here 5 as a base. Is up to you. There is no problem. But I would like to use the right hand side to change the base. And this is 5. Like here, if I make this 5 as a base, like when you here, like we are not you're doing interchange of base. We are doing the third. We need third base. Third base is log 5. Like here, I have discussed with you, right? Log 2 times. Here you have to write 2 minus x, and here you have to write under root 5. The third base is 5 and 5. Now this is the way what we can do. This will remain same. I just need to copy this. 5 minus 4x. Here in right hand side, when you see this, this 5 power is 1 upon 2. Can I write 1 upon, like 5 power is 1 upon 2? Okay, this 1 upon 2 will become like here power law. This will 1 upon 2 will become the coefficient here. I'm writing 1 upon 2. And log 5 please remember log 5 is equals to 1. Like log 5 is equals to 1. So this will become 1. This is 1. So we have only 1 upon 2. And 1 upon 2 means when you write 1 upon 2 here, this 1 upon 2, when we move up, this will become only 2. Now, by this method, this 2 now will become the power, because I have the option to remove. So this 2 will become the power, and we do the comparison of log with both the sides. So what we have now, normally we do not cancel. We have just 5 minus 4x is equals to 2 minus x the whole square. Now just very simple to do the working here. I know you can do the working. This complete square formula is 2 square minus 2 to the 4x and plus x square. And 5, like when we simplify this, x square minus 4x is cancelled out. We have only is equals to 5. X square is equals to 5, and for minus 4, and finally is coming x squared is equals to 1. So x is equals to plus minus 1. So now after this, you have to check out this. Do we have both the answers plus 1 minus 1 or just only one answer? So here, when you consider 5 minus 4x, 5 minus 4x should not be like here. This should not be negative, and this 2 minus x also should not be negative. So when you write plus 1, 4 times 1 is 4 is coming positive. 1 is possible. When you write 1 here, 2 minus 1 is also 1. When you write minus 1 plus 4, when you multiply is coming plus 4, like here, minus 1 is coming 9. And when you write minus 1 here is coming 6. So both are possible. So it means plus minus 1, both the answers are right for this question. Now moving to next part, which is our question number 16. Let's see what we have in 16 now, the star question. In question number 16, the base is a. The base is a and there is 1. So there is no problem in this part, I think so. The log ax, and this one you have to write here, like 1 is a and a is also 1, because what you need the base, whatever the base required. Sometimes we write lg10 is also equals to 1. Log 5 is also equals to 1. But what we need the base here a, so we write a and a. Then we have plus log a and 7x minus 10a. Okay, let's see. This 2 will become the power, okay, and log a plus same basis, plus means we have to write product law, means plus will become like multiply one single logarithm a. This a times 7x minus 10a. Now comparison both the sides. This is like cancel out. We can say we normally do not cancel actually. Okay, now when we remove this, I just remove this. When we remove this, we have only this situation. Now, x squared is equals to 7ax minus 10a squared. When we simplify, is coming 7ax plus 10a squared equals to 0. Now, when you make the factors, factors are plus to get 7 means, yes, 5ax and 2ax. 5 times 2 is 10 and 5 2 is Like when we add is coming 7, is coming 10a squared. Okay, common is x is common. So we write x minus 5a. And what is common in the second part? Minus 2a is common. X minus 5a. Yes, same. So x minus 5a and x minus 2a equals to 0. X is equals to 5a and x is equals to 2a. Okay, this one thing very important here. Once again, this we have here one thing. This, please look at this. This x. Only this part is enough here. Log a with x. This x is 5a and this both are negative. There is no problem. But when we move to this part, do we have the both answer right? 7x minus 10a. When you substitute x is 5a here, like here, when I write 5a, your answer is coming negative or positive? 5 times like is coming positive. But when you substitute here, 2a is also coming positive. So let's check the answer. Answer is here. Yes, answer is here. Like 2a and 5a both are possible. Okay, that's good. So next is question number 17, and you have to wait for 17. Let's see. 2739. 2739 means I can make this 27 as 3 power 3 times 3 power is LGX. Remember, LG means base 10 is equals to 9 is 3 power square, and I write in the bracket the whole term 1 plus LG x minus 20. Okay, please do not cancel here like 3. First we have to write the single like base. This 3, this both the powers will be added. 3 plus LGX and 3 power 2 will multiply 2 plus 2 LG x minus 20. Okay, now what we have to do here, this one, now we can like compare the powers. We do not cancel actually, please. 3 plus LG x is equals to 2 plus 2 LG x minus 20. 3 and 2, when we move 2 in left hand side is coming 1. So I am writing 1. Okay, LG x plus 3 and minus 2 is coming 1. Okay, I'm writing 1. Then 2 LG x minus 20. This one, in the last question we use LGA log AA. This is LG10 is equals to 1. So this one I will write here now LG10. I have the option to remove. Okay, so you have to use the next line. This plus means when you write single log, I have to write x multiplied by 10, and here 2 will become the power. Okay, let's see what's the next part. Here I have to write here when we cancel this, like we do not cancel actually, we're comparing the power. 10 x10 is 10x, and this x we have to write a square minus 2ab means of this formula 22 is 40x, and this will become 400. Okay, this is complete square formula I have used here. So x square minus 40x, this 10 when we move here is minus 10 is minus 50 altogether, and plus 400 equals to 0. X square factors, I think so, factors of minus 40x and minus 10x. Yeah, 5 is 400. Okay, when we take the common is coming x minus 40, minus 10 is again x minus 40, yes, equals to 0. So x minus 40 and x minus 10 is equals to 0, x is equals to 40 and x is equals to 10. Okay, the problem is here, like when we get the results, we have to verify this which is rejected. Sometimes we have to check. You can see log x is here in the power. Okay, LGX is here in the power. This is enough. X is okay, 10, and this is x minus 20 is also there. LG x minus 20. When I write 40 here, this is LG 40, there is no problem. Even you can write LG 10. But when you write LG, like when you put the value 40 here, 40 minus 20 is what? 40 minus 20 is 30. Accepted. But when you substitute 10 here, what's the result? 10 minus 20 is coming LG minus 10. Okay, this is rejected. This value is rejected. This is rejected, this is accepted. This is the way, like when we have the results at the end, always check the value, put the value in with the log and something, the value of x. If the value of x is some negative, then you have to reject the results. So by this way, we have done 3.6 question number 15 to 17. I will continue, this video will become very lengthy when I move to the past subject question. So I think so I will continue with the same like past subject questions which I showed you in the beginning. So thank you so much and have a nice day.